Go. Number 31. A 40-kilogram box initially at rest is pushed 5 meters along a rough horizontal floor with a constant applied horizontal force of 130 newtons. If the coefficient of friction between box and floor is 0.300, find A, the work done by the applied force, B, the increase in internal energy in the box floor system due to friction, C, the work done by the normal force, D, the work done by the gravitational force, E, the change in kinetic energy of the box, and F, the final speed of the box.
Okay, so chapter 7, number 31. So we have a 40-kilogram box being pushed on by a 130 Newton force with kinetic friction opposing it, and then we also have the mass times the gravity is 392 newtons downwards, and then we have the normal force off the ground pushing back upwards, those canceling out. And then the distance the box is being moved across is 5.00 meters. So what we're going to find is the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction, which is the normal force minus 392 newtons, and then that's going to equal 0 because they cancel out. So we know that the normal force is 392 newtons also. So therefore the force of kinetic friction, which is equal to mu k times n, is 0.300 times 392 newtons. So the force of kinetic friction we now know is 118 newtons. Because of that, we can now start our problem. So for number A, we're trying to find the work. So the work is the force times the change in distance times the cosine of theta. Because there's no angle, we can assume that it's 0. So we're going to do 130 newtons times 5.00 meters. So that's going to be 650 joules. Part B, we're trying to find the internal energy. The internal energy equation is the force of kinetic friction times the change in x, which is 118 newtons times 5.00 meters. Therefore, we get 588 joules. For part C, we're trying to find the work of the normal force, which is equal to n times the change in r times cosine of theta. We're going to get 392 newtons times 5.00 meters, and the angle on this one is going to be 90, which would make it 0. Therefore, there's 0 work being done, so there's 0 joules. Then we're going to do the work of the gravity, which is going to be mass times gravity, which is force. And then it's going to be multiplied by the change in r cosine of theta. Again, this theta is going to be negative 90, which is also going to create a 0. So there's going to be 0 work done by gravity. Okay, now we're going to go on to part E. Part E wants us to find the change in kinetic energy. So what we're going to find is K final minus K initial. And because we know that the change in kinetic energy is also equal to the change in the work minus the internal energy, what we're going to do is 1/2 mv final squared minus 0, because then we're going to find that 650 joules is minus 588 joules is equal to 62.0 joules. So that's going to be the change in kinetic energy. For F, we're trying to find V final. V final, the equation for V final is the square root of 2 times the kinetic energy final over the mass is equal to the V final. So when we plug in all the values, we get V final is equal to 1.76 meters per second. If you're wondering where we got this equation, it's just 1/2 mv final squared, and then with a little algebra, you get the equation, the square root of 2 times kinetic energy final over the mass. And that is the problem.